Hello, students. You are welcome to the fourth session of Unit 5. In this session, we shall be considering factors in choosing examples and tasks. Let's look at the session objectives. By the end of this session, you should be able to identify some factors to consider in choosing mathematical examples and tasks. In our previous session, we looked at mathematical analysis and we talked about 3 questions to consider when doing mathematical analysis. The teaching of mathematics is based on the premise that you have something important to convey to students, and we looked at that particular thing when we talked about objects of learning, that there's something that we want our students to learn or to know or to be able to do at the end of our lesson. Now the question then is, how do we sustain students' interest in the next question? In the next question to ask. Or the question is, how do we sustain students' interest? So if we have something that we want our students to know or to be able to do at the end of our lesson, how do we sustain their interest then? This requires that we think carefully about the kinds of examples that we choose and the tasks that we give to our students to do in order to sustain their interests. So the focus of this session is to look at the kinds of examples we should give to our students and its associated tasks, as this will serve as means for students to grasp the subject matter that we are teaching as teachers, or as mathematics teachers to be specific. Since mathematics is an abstraction, we must present our subject matter in a way that students can make sense of them. And we all know that from our previous lesson, we've seen that most of the concepts or topics in mathematics are abstractions. So we must present them in such a way that the students will see the reality, or will can be able to make sense out of the abstractions that we are talking about. And one way of achieving this is by providing examples of the said objects of learning. So one way of making our students see the sense in the abstract nature of mathematics, or the topics that we treat, which are mostly abstractions, is to provide them with examples of whatever object of learning we are dealing with. It is important that you choose examples carefully so that they convey the concepts. So the examples that we choose should be related to the concept and should be able to convey what the subject matter is. In choosing examples to exemplify a mathematical subject matter, it is important to consider the following questions. So in this session, we shall be looking at some important questions to ask when we are choosing, or we want to choose examples to exemplify our mathematical subject matter. And the first question we should ask is, how will the examples that we choose enable students to make the necessary generalizations, thereby avoiding overgeneralization? In our previous session, we said that mathematics is connected. We should teach mathematics as connected body of knowledge and not single or separate entities. So the first question we should ask is, how are we going to choose our examples to enable students to make the necessary generalizations? And by this, we can look at it in these ways. It should be possible for students to know what the critical features of the mathematical object is. And by critical features, we mean what actually the mathematical ideas that we want to present to the student. They should know what those things are. And when a mathematical rule or convention applies, most of the topics in mathematics deal with formulas, rules, and conventions. So we must be able to let the students know when each of the rules applies. Without clear opportunities for students to learn when particular rules, for example, apply, they will be making mistakes and be making or misapply the rules. So if we don't do that, if we don't let them know when the rules or conventions apply, there's a tendency for them to misapply the rules. You see, you are teaching a topic in mensuration, and the students will be using a formula that you have taught them somewhere in trigonometry that does not apply to that particular concept that you are teaching. So we should let them know when the rules apply. To help students avoid overgeneralizations, it is important that the examples you choose offer opportunities for students to observe similarities and contrasting cases. So the examples should be able to let the students see the similarities between the rules and conventions, and for them to contrast the cases and see that no, this rule cannot be applied here, that rule can be applied over there, and so on and so forth. So it is quite possible for students to solve a variable even though they have been given an expression or misapply the BODMAS or PEDMAS convention. It's possible that when you give your students what they call it, an expression that they have to use BODMAS procedure or PEDMAS procedure, they will misapply those rules because they don't know when those rules apply, whether to start with bracket first, multiplication in that order. So there's a tendency of them misapplying the rules. So let's look at an example. If you give examples such as the one you can see on the board, look at the linear functions that you can see. So something like this, you see this is abstraction. So you must be able to present the concept in such a way that the students will be able to identify the similarities and the contrasting points for each of them. So questions that you can ask: determine what features of the equation is staying the same across the example. So they look at the functions given, they look at what is constant or what is not changing at all, and you realize that the y-intercept is staying the same. That is 1, 1, 1, 2x plus 1. The y-intercept there is 1. Y is equal to 3x plus 1, still 1. 1 half x plus 1, still 1. And then negative 2x plus 1. So all these ones, they realize that the y-intercept is staying the same. And then you can ask, what feature of the equations is varying? What is changing? And you realize that the coefficient of x, which they should know is the gradient of the line, or when they sketch the graph, that coefficient of x determines the slope of the line. And that is, if you look at the equations, the 4 equations, you realize that the coefficient of x is the one which is varying or changing for the 4 equations. And then after this, they graph the various equations on the same graph and then try to compare and contrast. So what can they generalize about the behavior of the graphs? And you think about the coefficients of s as affecting the steepness or the slope of the graph. So after drawing all the 4 graphs on the same graph sheet, they realize that these features are similar, others are different, and they need to make generalizations whenever you are given whenever they are given different sets of equations to graph. The second question we should also ask is, in which sequence would the examples be given? So when giving your examples, what sequence do you give your examples? And questions you should ask about this is, are you going to start from simple to complex or complex to simple? This is a very necessary question to ask. And then, are you going to introduce the concept with an example, with a problem, and teach the mathematical concept through problem? So are you going to introduce the concept by giving the students a problem, and after teaching the concept, they will use that particular concept or what they have studied or learned to solve the particular problem? So you should look at the sequence in which your examples are given. And all these are questions that you need to address when you are deciding on the examples to use. And this will help bring a mathematical idea or principles to light. So when you ask all these questions, you are able to find answers to them. Then you are able to bring mathematical idea or the principle that you want to teach to light. So what's a task, or what is a mathematical task? When we say a mathematical task, it's a problem or a set of problems that focuses students' attention on a mathematical idea. That is according to Stein et al. 1996. So a problem or a set of problems that focuses students' attention on mathematical idea is what we describe as task. You must know that to every example you give, there is an accompanying task which spells out what you want students to do with the example. So you give them the examples and accompany them with tasks that will spell out what you want the students to do with the example. So we can give examples of tasks as carry out known operations, examples factorize, solve, find an angle of measure, or apply known skills, or choose an appropriate procedure. Example, classify them, match representations. So after getting the concept, you apply the known skills that they have learned. And then the third one, apply concepts or make connections. Example, you prove. So proving is about applying concepts and making connections. So you prove a multi-step problem. All these things constitute application of concepts or making connection between concepts. So, ladies and gentlemen, this is what we mean by mathematical tasks. And you must take note that every example, there must be an accompanying task which spells out what is you want the students to do with the examples. With this, we have come to the end of this session, and this one I'll leave you with this research problems. You research on Reyes et al. 2009. They look at some factors to consider when choosing mathematical tasks. So you research about it, and then you identify 4 of their factors and explain them, and also explain what is meant when we say tasks have multiple entry and exit points. So you look at these questions, and when we meet in our next session, if you have any challenge, let's